Okay, so lesson 6.2 is talking about matrix inverses. So the inverse of a matrix, if I take a matrix times its inverse or the inverse times the original matrix, I will get the inverse. So a lot of times we think about that when let's say we're just talking normal multiplication, you could think of that as a reciprocal. So 3 times 1/3 is 1. It's kind of the same idea, but with a matrix, it's a lot more complicated than that. So they want me, in example 1, they want me to decide whether whether B is the inverse of A. Okay, and they're telling me that I can decide that by computing these two things. So I want to show you what happens when I do that, okay? So if I take A times B first, so we got to remember how to multiply, right? So first, if I take A first, I have to go across A and down B. And that's how I always remind myself of that, because I really get confused with this. So I would say across and down. So across means I'm going to take 1 first and I'm going to multiply it by -2. Most people get that one, but then they go the wrong direction. So the second one, so I'm going to add 2 times 3/2. Okay, and then the position next to that, I'm going to stick with 1 and 2. So stick with 1 and 2. But this time I'm going to go down this one. So 1 times 1, 2 times -1/2. Now, from there on, I always like to go through here and just put those parentheses in, because I know what's going to go next. I know that down here, this is going to be -2, and this is going to be 3/2 again, and this is going to be 1 again, and this is going to be -1/2 again. So then you can kind of fill in what you're missing. And if this top line up there was 1 and 2, then this second line would be 3 and 4. Okay, so then I'm going to actually calculate that. So this is going to give me a -2. This will cancel, so that gives me a 3. A -2 plus a 3 is 1. On this one, I get a 1 plus a -1, because those 2's cancel. 1 plus -1 is 0. And then 3 times -2 is -6, plus that cancels and gives me 6 total, so that'd be 0. Again, you can use a calculator for that if you need to, if you're not confident in that. And then 3, this would be -2, which would be 1. So what you should notice is it ends up in that simplified, that reduced form that we had kind of talked about previously, where there's 1s diagonally across that way. Everything else should be 0. So this one is good. If I do BA, that would give me, in this case, so if I do B first, that means I'm going across this time and down this one. So across this one means I'm going to use -2 and 1. And I'm going to use the same thing here, -2 and 1. So then the question is, what do I put in those parentheses? So I put this first column, so 1 and 3 for the first one, and then the second column for the second one, that would be 2 and 4. Okay, so then for this one, I'm going to do the same idea where I know I'm going to have the 1 and 3. Some of you may have a different method to this than me. If you do, and if you think it's much more useful than my method, please let me know, because I feel like I just kind of stumble my way through it every time, and it's kind of hard to explain to people sometimes. Okay, so I went across this one. Now I have to go across this one. So these two are going to be 3/2 and -1/2. So 3/2, -1/2, which means I could have written this as minus, but I'll leave it the way it is for right now. Okay, so then let's simplify this. So this one gives me -2 and 3. -2 plus 3 is 1. This would give me -4 plus 4, which is 0. So I'm hoping for a 0 here and a 1 here. So 3/2, this would be -3/2, which is 0. This would be 6/2, or 3, -2, because half of 4 is 2. 3 minus 2 is 1. So that worked also. So If you get this for both of them, so if A times B, so remember up here, if I take the matrix times its inverse, I should get that, what I would call reduced form. And then same thing with this one, if I take the inverse times it, I would also get that reduced form. So that's what happened here, both of those happened. So sometimes they'll give you this terminology right here where they say like dotted triangle, B equals the inverse of A. This is like your conclusion. So therefore, B does equal the inverse of A. So this is my conclusion. Okay, this second example, this is my absolute favorite part of chapter 6. So finding the actual inverse. A lot of people get super frustrated with it. For some reason, I really like it. So you guys will just have to let me know how you feel about it. So example 2 says find the inverse of this. So here's how I do that. I say I'm going to take that matrix and I'm going to turn it into that reduced form, which looks like that. So I want to try to get from this to this. And what's going to happen when I trade these two places, what's going to happen is the part that's left over here is the inverse. So let me show you what I mean by that. I'm going to try to get this 2 to be a 1. So that's always the first one I look at. I always look at that first corner. How do I make that a 1? Well, the best way to do that would be to divide it by 2. But we always talk about this as multiplication and addition or subtraction. That's all I ever talk about. So in this case, I would say I'm going to take half times row 1. And the reason why I said row 1 is because when you do something like this, you have to do it to the entire row. It's kind of like doing the same thing on both sides of an equation. You have to do it to the whole thing. So when I do this, I'm going to find half of every one of these terms. So half of that is 1. Half of 1 is 1/2, which isn't super pretty, but I can fix that later. Half of 1 is 1/2, so I'm going to kind of put this divider in there again so I keep them separate. Half of 0 is 0. This bottom row did not change at all. So make sure when you're doing this, you change one row at a time. Don't mess with the other. Okay. The next thing that I would do, I would try to figure out if I've got this to a 1, that means that one's done because it was supposed to be a 1 right there. The one below it should be a 0, so I'm going to try to mess with that one next. Okay, so once you have one in your row, then you can usually figure out the other one. The easiest way to do the other one is say, you know what, if I take, so you can like work with these together, and that's the part that usually confuses people. But if I want to make this a 0, I can't just multiply by something because you can't multiply by anything and make this a 0 unless you multiply everything by 0, and that's going to be really odd. So instead, what you have to do to make something a 0 is add or subtract something from another row. So what I'm going to say is I'm going to take row 2, which is this row, and I'm going to subtract 5 times row 1. I'll think that through for a second. If I subtract 5 times row 1, well, what's 5 times row 1? That'd be 5, right? In this position. I don't care about the others right now. I only care about this one. That would make that a 5, and 5 minus 5 is 0. So what I'm going to do is I'm going to make myself a little note. I'm going to do this piece up here above it so that I know what I'm subtracting every time. So if I take 5 times this, that's 5. So I'm going to subtract a 5 on that one. If I take this times 5, I'm going to be subtracting a 5 over 2. This one, I would be subtracting a 5 over 2. And this one, negative 5 times 0 is just 0. So I'm not subtracting anything, subtracting 0 there. And then I'm going to actually subtract those things. So 5 minus 5 is 0. And then 3 minus 5 over 2. So think of this as 2.5. 3 minus 2.5 is 1/2. And then the next one, so let's put our divider in here. 0 minus 5 over 2 is going to be negative 5 over 2. That one was easy. And then 1 minus 0 is 1. Again, my top row I didn't change. I only did this piece. So wherever I'm writing this, that's the row that I'm changing. Okay, so that top row is going to stay 1, 1/2, 1/2, and 0. Okay, so now I got to think about how do I get, so I'm kind of going in a counterclockwise way here. I want to get this one to be a 1 before I worry about this one being a 0. Because remember, once this is a 1, making this a 0, you can do it in this same way every time, this same thing. So I'm more focused on getting this to be a 1. How do I make that a 1? If I take 1/2 times 2, that'll make that a 1. So I'm going to take 2 times row 2. So this whole row times 2. Now I'm going to go down here and finish this one up though. Okay, so 0 times 2 is 2. 1/2 times 2 is 1. Negative 5/2 times 2 is negative 5. And 1 times 2 is 2. And then my top row stayed exactly the same. 1/2, 1/2, and 0. Okay, so let's see where I'm at here. Oh, what did I, look at what I did. 2 times 0 is not 2. I was like, how did I make it worse than I already did? Okay, so there we go. That's much better. So 0 times 2 is 0. 1/2 times 2 is 1, and so on. Okay, so now I've got this one done, this one done, this one done. All I have left is this one. I need to make this a 0. So remember, this is what it has to look like. This has to be a 0. How do I get that to be a 0? What I would do is take my row 1, the one that I'm on, this row, and I'm going to subtract away half of row 2. So if you look, this piece right here and this one right here are very similar to one another. That's how I can get that to be a 0 every time. Okay, so that gives me, let me go ahead and write this down here. So half of row 2, I'm going to do this piece right here underneath here so you can see it. So half of row 2 means I'm going to be subtracting 0 from this one because 0 times 1/2 is 0. 1 times 1/2 is 1/2, so I'm going to be subtracting 1/2. That makes sense. That's how that gives me a 0. This one, I'm going to take half of negative 5/2. So that's going to give me positive, I'm going to be adding a 5/2 because it's a negative and a negative right there. And then half of this, subtracting it, would give me -1. Okay, so now I'm going to put these together. 1 minus nothing is still 1. Half minus 1/2 is 0. 1/2 plus 5/2. So let's think about that for a second. So 1/2 plus 5/2, that'd be 6/2, which is 3. And then 0 and a -1 would be -1. Down on the bottom, I had a 0, a 1, a -5, and a 2 that stayed exactly as it was. So leave those alone. Now this side is good to go. So that means this side is my inverse. So the inverse of A is this matrix. 3, -5, -1, 2, depending on how you write it. Okay, and then I'll do a separate video for a bigger matrix, a 3 by 3.